This particular forecasting module will deal with winds and clouds in terms of using the help menu on the forecast exercise. I think before we begin though, let's go ahead and open up weather products. And I'm going to copy and paste this to another browser here, so we can just toggle back and forth between the forecast page and the weather products. Okay, let's go down here, and again we're going through just looking at the different help topics here to understand exactly what you're forecasting for. Let's take a look at this daytime cloudiness and temperature. Now for daytime cloudiness, probably what you should do at this point is go ahead and pause the video to read this particular paragraph on what constitutes significant cloud cover. Okay, as you can see, the site you're reporting for is evaluated for these particular times right before 18Z, 15, 16, 17, and 18Z, so we use the 4 hours leading up to and including 18Z, and if 2 or more of these hours report at least 75% cloud cover, then we say that clouds are holding daytime temperatures down. It's the same thing with 12Z. We'll just take the hours before that, and we'll look at that in just a few minutes. If you look at this particular link here, it lists the conditions. Again, you look at the center of this station model, and if it's not filled in, it's considered clear skies. Scattered condition is quarter of the sky covered or half of the sky covered. If 75% of the sky is covered, we consider this broken, and if the entire sky is covered with clouds, we consider it overcast. So what we're looking for is this broken to overcast. And we're looking if any 2 or more of these times report at least broken clouds, which is 75% cloud cover or more. We will consider that as meeting the daytime criteria. Now this particular graphic here shows the effect of clouds, and shortwave radiation coming in from the sun is often reflected by the clouds, and without clouds it reaches directly to the surface. So we see the effect that clouds can provide. They can keep daytime temperatures down, or they can increase temperatures if they're absent, if clouds are absent. Okay, let's go through, and next we will go to we'll take a look at clouds at night, because you also have to forecast for cloud cover at night. And you may just want to pause the video module here just for a moment to read this explanation of radiational cooling. Okay, we know why cloud cover keeps our temperatures warmer. We've covered that in Chapter 2. Again, the ground emits infrared radiation. The clouds absorb it, and when the clouds absorb the infrared energy, they gain energy and they emit infrared radiation back to the surface, thus keeping us warmer than without clouds. Okay, the criterion for determining whether there's significant cloud cover is whether there will be 3 or more hours of at least 75% cloud cover in the 6 hours preceding. So we look at 7Z all the way through 12Z. Okay, if we're making a forecast for 12Z tomorrow, if 3 or more of those hours have at least 75% cloud cover, then we consider that significantly affected by cloud cover. Again, you've seen this particular part here in terms of sky conditions. And this particular graphic here shows that in clear nights the Earth emits infrared radiation away from the surface off into space. Thus temperatures stay cooler, as indicated by the snowman. With clouds, infrared radiation is emitted, It is absorbed by clouds. Clouds then emit infrared radiation back to the surface, keeping nighttime temperatures warmer than without the presence of cloud cover. Okay, let's go down to wind speed, because you have to forecast wind speed at 18Z, 12 o'clock noon, and also wind direction. Let's talk about how wind speed is determined. You may want to go ahead and pause the video module here just for a moment to read this particular set of instructions on wind speed. Okay, let's take a look at some examples of wind speed. Again, we're looking at a station model. This particular direction here is northwest, and this half barb here, or this half line, indicates 5 knots or 5 miles per hour. You see here with one full barb, 10. This particular one has a full barb and a half barb, which would correspond to 10 plus 5 equals 15 knots, and so on. If you have a flag here that's filled in, it's considered a 50-knot wind. If you have a flag and a full barb, that's B-A-R-B, barb, that would be a 60-knot wind. And then, of course, if you have calm winds, you just draw a circle around the circle. Now let's actually look at a few PowerPoint slides in trying to determine how to predict for wind speed and direction. It's actually not that difficult. We can actually look at a surface map, which is what you're looking at currently here. We have, on this particular map here, we have an area of high pressure. And you see these circles here, these white circles. These are isobars, lines of equal pressure. Isobars, that's a term for you. Isobars, lines of equal pressure. And you see they spread out. You'll also notice the spacing between each of the isobars. Look at the spacing around this high, this isobar, and this isobar. And then when you get up into New England and into portions of southeastern Canada, notice that the isobars become more tightly packed. If your isobars, which are lines of equal pressure, are tightly packed, or they're occurring over a very short distance, then that's indicative of faster wind speeds. So over New England and portions of southeastern Canada, we would expect stronger wind speeds here than over the Midwest, where these isobars are kind of spread out. So if the isobars are spread out, the winds are lighter than if they're packed together. We also know that around high pressure, winds are clockwise, just the way I'm rotating the cursor. Around low pressure, winds are counterclockwise. So high pressure clockwise, low pressure counterclockwise. The surface wind, which is what you're predicting, will basically be parallel to the isobars. Not exactly, but pretty close to it. The wind speed, as I mentioned earlier, will be proportional to the spacing of the isobars. So if they're tightly packed together, wind speeds are faster than if they are spaced out. As I mentioned, circulation around high pressure is clockwise. Circulation around a low pressure is counterclockwise. So we have a surface map here. Now this map is a little bit more difficult to read, but you see high pressure here in the center. And so we know that winds around high pressure are clockwise. And so just a point of reference, this is Missouri and Illinois, and then this is the eastern portion of the U.S. that I'm outlining here. So if you are to the right of a high pressure, such as the eastern U.S., you'll see winds coming out of the north or northwest. If you are to the left of a high pressure, and typically recall that weather moves from west to east, and so we would expect this high pressure to move toward the east or northeast or to the southeast. So high pressure has already passed by Iowa. And on the backside of high pressure, this region here to the west, typically you'll see southerly winds, southwesterly winds. In this particular, you actually have an east wind here, southeast wind here, and southwest wind here. So in front of the high pressure, northerly winds, and then as you come back around the backside of high pressure, you begin to see a southerly component of winds. Now around low pressure, it's the opposite. We know that winds around low pressure are counterclockwise. So with this low pressure sitting over, it looks like it's just near Milwaukee, Wisconsin. And so winds, again, low pressure, weather systems tend to move from west to east. And so this low pressure will continue to move off to the eastern U.S., or to the northeast, or to the southeast. So this low pressure system has already passed Iowa. So winds behind a low pressure system are out of the north, northwest. We see stations here, this station, which is Des Moines, is showing a west-northwest wind. Up in northern Iowa, we see a northwest wind. And up over, let's see, this would be South Dakota, it's a north-northwest wind. If you are to the south of a low-pressure center, your winds will be out of the west. If you are ahead of a low-pressure center, Cleveland, Ohio is somewhere here where I have the cursor. And so we see that winds are from the south, out ahead of the low pressure. So just by looking at pressure systems, low pressures and high pressures, you can get a pretty decent idea what your wind direction looks like. If you're to the north of this low pressure, the wind direction here, it's out of the east. And so we've got east winds to the north of the low pressure, southerly winds, southwesterly winds, westerly, southwesterly winds to the south of the low pressure. Fronts. We can infer wind direction around fronts. If you are near a warm front, you'll typically have either an easterly component ahead of the front, east, northeast, southeast. If you are behind a warm front, your wind directions are going to be southeast, south, or southwest. So depending upon where you're located, either ahead of the warm front or behind the warm front will determine where your winds are coming from. If we're looking at cold fronts, typically out ahead of a cold front, which is where you have the warm, muggy air, the winds are out of the southeast, south, southwest, or west. It makes sense. If we're ahead of a cold front, the air is typically warmer. We probably have some sort of south-southwestern component. Behind the cold front, where we get cold air coming in, we typically have west, northwest, or north winds. This particular map here, you see the presence of a warm front. And notice these half circles. They're pointing off to the northeast. So that indicates that this warm front is moving from your lower left to upper right. And I don't know if you can see this cursor because the cursor itself is white, but the warm front is moving in this direction. So this station here that's sitting here with a temperature of 12 degrees, in a few hours this warm front will pass it and temperatures in the 20s, as we see here, 21, 28, 28. The warmer temperatures will begin to move into this particular area. This is the region ahead of the warm front. And so we have east, south, actually these are southerly winds here. Back behind the front, the warm front, we have west, southwest winds. The next picture shows a cold front. These are the triangles that we typically see, and they show up as blue on most surface maps. This front is moving in this direction. Okay, it's moving in the direction that these triangles are pointing. And so this station sitting here, which is currently 40, when the front passes, temperatures are back in the 30s. So temperatures will decrease. Notice this region ahead of the front. we have southerly winds ahead of a cold front. Behind the cold front, we have west-northwest winds bringing in cooler air. So just by seeing whether you're ahead of the cold front or behind the cold front will determine wind direction. Well, what about wind speed? If we know that winds around a high or clockwise, winds around low pressure or counterclockwise, and we know the wind direction ahead of a cold front, behind a cold front, ahead of a warm front, behind a warm front, but what about wind speed? Well, there's a little rule of thumb you can use for wind speed, and it depends upon the spacing of isobars. So, for example, if we have 2 isobars or less, the wind speed will be less than 5 knots. If you have 2 to 3 isobars across Iowa, your wind speed will be somewhere between 5 and 15. 3 to 4, 4 to 5, 5 to 6. If we have 5 to 6 isobars, these are lines of equal pressure, then we can expect 25 to 35 knots. So we go from wide spacing of isobars to very tightly packed isobars. So let's go to this next slide, and this will actually show up. We have the state of Iowa here, and notice we have an isobar here and an isobar here. We really only have one isobar across Iowa, so the isobars are very widely spaced across Iowa. If we go back, we have less than 2 isobars. That corresponds to a 5-knot wind. If we go back and we look at the wind speed here in Des Moines, we see we have that half barb, which indicates 5 knots. Western Iowa, 5 knots. So we would expect light winds with these spacings of isobars. Let's take a look at an example of 5 isobars, or actually 4 isobars. One here along eastern Iowa, so that's 1, 2, 3, 4. So we have tightly packed isobars, and so we have 4 of those. Let's go back to this, and we see that if we have 3 to 4 or 4 to 5, our wind speeds can be anywhere from 10 to 20 or 15 to 30. Let's go back and look at that map again. So it looks like we've got 3 isobars and almost 4, so we'll call that 3 to 4. So with 3 to 4 isobars, we would expect winds between 10 and 20 knots. So I would expect winds to be 15 knots over Iowa. Let's look at that. We see wind speed of 20 knots over Des Moines. So 15 to 20 knots is accurate. So that gives you an idea of using isobars, or the orientation of isobars, to forecast for wind speeds. Now, we talk about regions behind low pressures. Remember, wind direction, wind speed. If we look at this, we have 1, 2, 3 isobars. That corresponds to 15 to 20 mile per hour winds. And you see across Iowa, we have 15 to 20 mile per hour winds. We also notice that our wind direction is from the north, northwest, which is this area behind the cold front. Or actually, this is an occluded front. But we're in this area behind the low pressure, because the low pressure will continue to move off to the east. And so behind low pressure, behind occluded fronts, west-northwest winds. What if you're in a region ahead of a low pressure and front? Notice Iowa here, and if we look back, Nebraska, and so we've got an area of low pressure moving into Nebraska, into Colorado, and so we're in this region ahead of this front. So we would expect southerly winds, and we see southerly winds. Now notice, if we're forecasting for the next day, these isobars are packed pretty close together. Right now we only have 2 isobars, so we would only expect winds anywhere from 5 to 10 knots. But notice the winds out here with the more tightly packed isobars, 15 to 20 miles per hour. So if I'm predicting wind speed and wind direction tomorrow, and if I predict that this front will move over to western Iowa by tomorrow, then I would expect my winds to increase to 10 to 15 knots because of these tightly packed isobars. And since I would still be in the region ahead of the front, I would still expect southerly winds, unless, of course, this front passed through. Well, I hope you've found this module to be a bit helpful in terms of winds and clouds. Have a good day.